We want to look at the time value of money. We want to look at the time value of money. And at the end of this chapter, you must understand, you must be able to understand and comprehend and relay the concept of the time value of money. You must also be able to determine the time value of money. You must be able to determine the future value, present value of an annuity, and the future value of an annuity. You must also be able to apply time value of money concepts. Okay, must also be able to apply time value of money concepts to given scenarios. Now let's start with a question here. Would you prefer to have $1 million now or $1 million 10 years from now? Now, the answer to this question depends on whether the 1 million you have now will still be able to buy whatever you want, what you can buy today. Are you able to buy it? Are you able to purchase it in 10 years if you choose to invest that 1 million? In fact, this question is actually saying you receive 1 million now and you receive 10 million, you receive 1 million again 10 years from now. Which one would you prefer? Of course, a number of you would prefer the $1 million now, because if you get it now, you'll be able to invest it and it grows into a bigger figure if you don't want to use it now. So your answer to this illustrates that there is an inherent monetary value attached to time. Okay, so when we are talking about time value of money, we usually say $1 received today is better than $1 received tomorrow. You'll see when we are doing what we call the dividend policy, there is a theory which is called the bird in hand theory, which says it's better to receive dividend now than to bank on capital gains. It's better you get the funds like today. So you would receive the $1 million today. Now, reasons for receiving the money today are as follows. Money received today can be invested to earn interest. Due to money's potential to grow in value over time, you would rather have it now than wait to receive a promised amount. In fact, what you can do is to check what is that amount that I'm expected to receive in 10 years. What is it worth today? Okay. So money held presently is considered more valuable than money which is to be received 10 years from now. Okay. Now the time value of money is not only dependent on time or the interval leg being considered, but also the rate of discount or the rate of interest that is used to calculate the current or the future value. Now, if you look at the discount rate, if you look at the rate, you must be able to say, now, given the inflation rate, am I getting the real value for money if I receive it a year from now? If I invest, for instance, at 5%, $100 at 5%, it means at the end of the year, I would be having $105. Now, if inflation is 10%, have I made the right decision investing at 5%, whereas inflation is 10%? It means I've not preserved the real value for my money. Okay. So, based on such understanding, we can use what? Time value of money concepts to calculate how much you need to invest or borrow now to meet certain future goal. Okay, how much given the interest rates and the times. Now, let's take these simple examples which you can see on your screen there. You need to sell your car and you receive offers from 3 different buyers. The first offer gives you $4,000 to be paid now. The second offer gives you $4,100 to be paid 1 year from now. The third offer gives you $4,600 to be paid 5 years from now. assume that the second and third offers have no credit risk, which means they will not default on their promise. What they've said is what they would do. And assume that the interest rate, the risk-free rate of interest is 5%. Which offer would you accept? Now I'm being tempted to send this as an assignment. You know, temptations. Okay, which offer would you accept from there? Which offer would you accept? Now, in trying to accept, let's consider the time value of money. I know you would accept 4,000 now without working out anything. But let's also try and apply the time value of money there. Now, we can receive 4,000 today, or you can receive 4,100 a year from now, or you can receive 4,600 6 years from now. I want us to assume something here. I want us to assume a compound interest here. We'll talk about compound interest as we go. Now, those are your expectations. Now, you are told, or we are told, that the rate of interest is 5%. So, in other words, let's see what is this amount equivalent to today. Now, 4,000 today is 4,000. Now, 4,100 a year from now, if interest rate is 5%, let's look at our tables. This is future value, interest factor. We want present value. Present value at 5% in period 1. It's 0. What? 0.9524. 0.9524. What about 5% in 5 years' time? 5% in 5 years' time, 0.7835. So 0.7835. Now, what is the, all right, let's check it. 5% is it now? The answer is 1 there. So PV, so what we have here are our present value interest factors. So PV there would be the figure that we have, which is 4,000 by 1. And the figure that we have there, which is 4,100 multiplied by that one. And that other one, which is 4,600 multiplied by that one. Okay. Now, let's check. Let's check which one is the biggest there. Equals, we want the max of this one, or this one, or this one. Which one is the highest there? So it's 4,000. So it's better to receive the 4,000 now. Are we together? But let us check something here. What if our interest rate was 1%? What if our interest rate was 10%? etc. You can actually be playing around with that. So it's better to receive. In this question, I know you're going to say, let's receive the 4,000. But from these workings, the present value equivalent of these amounts, 4,100, 4,600, are less than the 4,000 that you can receive today. So if we are checking that, we would accept the first offer there. Okay. Okay. Now, in time value of money, there is an important concept of interest, which has to be understood. What is interest? What is interest? Now, when we're talking about interest, we're talking about a rate which is charged or paid for the use of money. Now, if you get money from me, the use of that money by you, those benefits which you derive from that money, when you are now paying back to me, it must not be free. So money has got a charge. Money has got a price. And the price of money is what? Is interest. So an interest rate is often expressed as an annual percentage of the principal. We have what we call a nominal interest rate. Now, if you take a loan at a bank and they say it's 17% per annum, that 17% is a nominal interest rate. Now, it's the one where the effects of inflation have not been accounted for. Now, when we're talking about real interest rates, we are saying these are interests where inflation has been accounted for, where inflation has been taken into account. Changes in nominal interest rates often move with changes in inflation rate, as lenders not only have to be compensated for delaying their consumption, they also must be compensated for the fact that a dollar will not buy as much a year from now as it does today. So they have to be compensated for the effects of inflation. Now, what are the components of interest rate? When we're talking about interest rates, what components must be captured by a particular interest rate? Now, when we're talking about what we call a risk-free rate, now government securities normally offer this risk-free rate. If you buy a bond issued by the Reserve Bank of Zimbabwe, issued by the government of Zimbabwe via the Reserve Bank of Zimbabwe, the rate that is quoted there is normally the proxy in our Zimbabwean market for the risk-free rate of interest. Okay? So interest rates must capture that. Now, assuming that the whatever security has been issued by a corporate and not by the government of Zimbabwe, not by the government of any particular country, it must also capture the rate of interest there, must also capture the expected inflation. To say, what is the inflation rate that we expect? So we might say risk-free rate plus adjustment for inflation. Then we have a real rate. Then we have a rate that might be accepted by investors. We also have the default risk premium. We look at the issuer of a particular security, say this security has been issued by XYZ. Now, what is the track record of XYZ of defaulting or of paying? Do they pay? Can we classify them under risk-free asset, under risk-free investors? Okay, if they are borrowing from us, will they repay? So we have to capture the default risk premium as well. We also have to capture the liquidity premium and the maturity premium. I want you to go and research on those two, what they actually mean in your own words. Okay, now let's look at two types of interest in time value of money. As far back as grade 4, people, you guys were learning, we're looking at that is simple interest. Now, simple interest, when we're talking about simple interest or under simple interest, the interest that you earn there does not earn further interest. You don't calculate interest on the interest that has already been earned. You calculate interest on the principal. So when you deposit money into a bank, the bank pays you interest. And normally that interest that they pay you is simple interest. When you borrow money from a bank, you pay interest to the bank. So simple interest is equal to the principal represented by P times rate times the time in years. Let's know that the time is normally in years. Now, if you have a question or a problem where we don't have years there, you have to change that to what? To years. Compound interest is interest paid not only on the principal, but also on the interest. Now, when I'm calculating compound interest, for instance, in that question, we are saying the final dollar, which might be the future value, is equals to the principal multiplied by 1 plus R, R being the rate raised to the power T. Now, for us to get the interest there, we'll have to say the final dollar or the accumulated amount there minus P. Then we get what? We get the compound interest, we get the interest there. So we can use this. If our T is 10, we still use that formula to get our accumulated amount, and the interest would be the accumulated amount minus the principal invested there. Okay. Now, what are some of the uses of the time value of money? We can use time value of money to a number of things in finance, including bond valuation, stock valuation, capital budgeting, which is project management, financial analysis of firms, and many others. You will see as we finish our corporate finance 1 and we go into corporate finance 2, you would see that you'll need to know time value. You need to have time value of money. You need to know it. Okay? Types of time value of money calculations. Now, there are many types of time value of money calculations. We've got the basic types that will be covered, which are future value of a lump sum, present value of a lump sum, present value of cash flow stream, present value of annuities. Those are type of calculations of what? Of time value of money that we are going to look at. Now, the basic rules of time value of money calculations, the following are simple rules that you should always use no matter what type of time value of money problems you are trying to solve. Stop and think. Now, if you look at our motto at NASIS, think in other terms. You don't just rush. Stop and think. Use your mind. Don't leave your mind home when you are working out these time value of money problems. Make sure you understand what the problem is asking. Don't just rush to answer. Okay? Draw a representative timeline. Drawing. Some people don't even want to draw because they are at university. Draw a timeline which tells you that this cash flow is in year 2, this cash flow is in year 5. This cash flow is being received at the beginning of a period. This one is being received at the end of a period. Depict that on a timeline. Okay? Write out the complete formula using symbols if you have to use formulas. If the question that you have, if tables are not applicable, just write down the applicable formula to say this formula is the one which would work here. Okay? Using symbols first and then substitute the actual numbers to solve. You know, if you do this, you might actually earn marks for doing that to show that you are organized. Now, you also might need to check your answers using a calculator after that. Okay? You might work out this. You guys are very bright, is it? So you can work out this using your head. Then you confirm with a calculator. Now, I've got a timeline there. It's not that good, but I can actually make it better there. Okay. Now, this will waste our time. But that's the timeline that we have. Let's have a question there. How much money would you have in 5 years if you invest $100 today at a 10% rate of return? Draw a timeline. Now, that's the timeline. 100 is at period 0. You are investing it now. And it will have to proceed. It will have to be invested for 5 periods. 1, 2, 3, 4, 5. For those 5 periods, it will have to be where? It will have to be invested. Now, as you withdraw it in year 5, how much will it be if interest rate is 10%? Now, your question there, the question now there should, let's check. Is it simple or compound interest? Because the answers will be different there. So I want you to work it on your own there as you are seated in the comfort of your home. Just find, if we are using compound interest, how much will you withdraw in year 5? But if it is simple interest, how much will it be in year 5? Okay. Now, let's look at what we call the future value of money. We would look at the present value of money as well. But let's start with the future value of money. The future value of money. Now, future value is the value of an asset at a specific date in the future. It measures the nominal future sum of money that a given sum of money is worth at a specified time in the future, assuming a certain interest rate or more generally a rate of return. The future value does not include corrections for inflation or other factors that affect the true value of money in the future. You are just using the rates that you have and the monies that you have to compound them or to just push them forward. What would be the other money equal to in the future? Okay. Now, under compound interest, when we are looking at future value of money, future value is equals to, we are saying FVN is equals to PV1 plus I to the power N. Now, this equation is used to determine the future value of an investment at some point in the future, where FV is the future value of the investment at the end of year N, I or R is the annual rate of interest. PV is the present value in today's dollars of a sum of money. So in that question of ours, where is that question of ours? There. You can write that formula. Then you choose to say what is our PV, $100, what is our I, 10%, what is our N, it's 5. So find the future value of that amount using that particular formula. Now let's look at the future value of a lump sum. Future value determines the amount that a sum of money invested today will grow to in a given period of time. If you receive $10 million today and you put it in a bank, XYZ bank, XYZ bank is paying 35%. What will that amount be 5 years from now when you want to withdraw it? Maybe you are saving for purposes of buying a house or purpose of buying a particular asset of your choice, or you might want to save for your wedding, even though you are not inviting lots of people for the wedding these days. You might want to save for that. How much will that money be in 5 years' time? How much will that money be in 2 years' time? So that's a lump sum we're talking about. Okay. Now, the question that we had earlier on is an example of a lump sum. Someone is saying $100, $100 a lump sum. Yes, it's a lump sum. Let's call it a lump sum for today. Okay, how much money? So you draw the timeline. That is the timeline. Write out the formula using the symbols. Now those are the symbols. FV at period T, which is 5, is equal to CF, not the cash flow you receive at period 0, multiplied by 1 plus R to the power T. Now 10%, you can calculate this manually and get that one. Okay. Substitute the numbers into the formula. FV is equal to 100 multiplied by 1 plus 0.1 to the power 5. Solve for the future value. So the future value is that one. Or you can also make use of your tables. 10% for 5 years, 10%. This is present value. Now we want future value. We want what? Future value. 10% for 5 years. Now where is 10%? Okay. 10% for 5 years. You look at how much it would have grown to. 10% for 5 years. Is it coming out? We might need to work it out. 10% for 5 years. We can say how much is invested, $100. At what rate? At 10%. For how long? For 5 years. So that's our T. That's our I. And that's our PV. Now what then is our FV? Now FV would be equals to